Welcome to Dear SQL DBA, a podcast for SQL Server database administrators. I'm Kendra Little. This week, our question is about how to deploy schema changes to SQL Server in a way where you can limit the downtime. Here's the question. Dear SQL DBA, how can I achieve near zero downtime deployment with database schema changes? Can I use peer-to-peer replication or some other feature to make this easier? It seems very complicated. We use SQL Server Data Tools, SSDT, and the developers work agile. Quite often they make small changes to the schema. We have found that there are some snags with it since SSDT generates the change scripts. Here's an example of a common problem that we've hit. When our developers add a column to a table, you often get a create, insert, drop table script generated by SSDT. Avoiding table locking when possible would help us achieve a near zero downtime deployment. So I totally get your pain. More and more, we want to ship features quickly with software, and there are tools that can help make writing the SQL scripts to generate changes much easier. SQL Server Data Tools is just one of those tools. There's other tools out there that do it too. And at the same time, we want to be able to release these changes in regular, frequent increments. We don't want to save all the changes up for a giant release. You know, historically, a lot of this, there's this waterfall release planning. And now that I think about it, I actually don't know why it was called waterfall. I think of going sort of over the waterfall in a barrel at one period, but that's probably not what they meant. But the idea is, if we can release lots of little changes and ship frequently, we can get feedback on the changes we make more rapidly. We don't have to have our teams bogged down trying to troubleshoot code that they wrote 3 months earlier. Things can be happier, but we don't want to be making things unavailable all the time either. So let's talk through this. The first thing is, I totally get why peer-to-peer replication seems like maybe it would make this easier, because peer-to-peer replication is a technology in SQL Server that lets you have multiple SQL Server instances that you can write to at the same time. Data replicates from the peer-to-peer nodes back and forth. So in theory, and the original question had some more detail around this, I cut it down a little bit, but the idea would be maybe with peer-to-peer, I could have all our application servers reading from one of the SQL Server instances, and maybe I could go deploy my schema changes to another one. Then, when the schema changes are done, I could point the apps over to the instance where I did my schema changes, and then after they're sort of drained off of that other node that's now idle, I can deploy the schema changes over there. Well, peer-to-peer wasn't designed for this use case, and it's not supposed to work like that. So if you check the documentation on peer-to-peer replication, one of the big things they say is your publication must be set up so that schema changes replicate automatically between the peers. There's a publication property called replicate DDL, and they say that for peer-to-peer replication, that has to be set to 1. Now I don't work with peer-to-peer replication all the time. I don't actually know if they enforce that requirement. You know, I don't know if peer-to-peer replication will actually not work if you set that to 0, or if it makes your replication unsupported. I don't think it matters, because you want to follow the rules either way. In other words, let's think about what would happen if we didn't replicate the schema changes automatically between the nodes. Let's say I'm doing this little dance, and I've got a table that I'm deleting a column from, right? Because I'm doing any schema change. And I have my node where I remove the column, and I don't have it set up so that that change automatically goes to my other node. Inserts are happening on that table at the other node, and of course, inserts are going to have to do something with that column, right? Either they're insulting a value or a null, but they're doing something with it. Well, how could SQL Server replicate that insert back to the node where I deleted the column, right? The column doesn't exist on one node. It does exist on another node. If I do inserts, updates, or deletes on rows in that table, what should happen? This is a big, big problem, and that's why you should have it so that schema changes replicate between the nodes to get you out of this sort of horrible conflict situation that you could get into if you didn't do that. It's like Schrodinger's column, like not like Schrodinger's cat. I don't know, is the column alive or dead? I feel sort of sick and in between. There are other reasons that I don't think peer-to-peer is a great fit for this either. There's going to be code changes that replication won't let you do while the table's in replication, like modifying a primary key. When you have new tables that your developers create, you're going to either have to add those manually into replication, so you're going to have to know about every new table that appears in the release notes, and either you're going to have to add it to replication, or a T-SQL script's going to need to be generated as part of the code release to do that, which is probably unlikely if you're automatically generating your code. When you add new articles in, or you remove articles from peer-to-peer replication, you're supposed to do what's called quiesce the topology. In other words, make sure that writes aren't happening, which is basically an outage, right? So when you're taking articles in and out, you're essentially having an outage you wouldn't otherwise have. And with any table level replication, if you have big tables and you update a lot of values, or you delete a lot of rows, or you insert a lot of rows, this all has to flow through the distribution database and into the subscriber. Your replication can get behind, you have something else to troubleshoot. You've got to manage conflicts if they get updated on multiple nodes, and which one's right. And peer-to-peer replication is in kind of a weird spot in SQL Server land. It's an enterprise-only feature. It's the only thing of its type, and it isn't compatible with a lot of other sort of celebrity features, I guess we could call them. It's not compatible with recent sort of big ticket features like availability groups and in-memory OLTP tables, which kind of puts peer-to-peer replication in an odd spot. It's a member of the expensive enterprise club, but it doesn't play well with the other sort of new celebrity members of the enterprise club, which kind of, to me, I'm not saying it's deprecated or anything like that, but it's sort of like, okay, well, what is the future of this? You know, like, is it going to get new things to make managing conflicts easier or anything like that? Or is it kind of just on life support? I don't know. So when it comes to this thing of I want to limit downtime when making schema changes, I don't think peer-to-peer replication helps with that problem in any way. I think it actually makes managing schema changes harder. In other words, if you really need peer-to-peer replication for other reasons, you can make schema changes work with it, but it's tricky, it's complex. I wouldn't put the peer-to-peer replication in to help with the schema changes because it's just not for that. So what about these problems? Well, there is, for the example problem, this is an interesting one. Why would tools like SQL Server data tools do something like, hey, when you want to add a column, why would they script out something that might seem crazy? Create a new table, insert all the rows, and rename and drop stuff. Well, that's not that crazy, because sometimes when you add a column to a table, SQL Server may do what's called a size of data operation, where it has to go through that table and touch and write to every single row in the table, and it's on a large table. That's a big operation that can take a long time, and it can generate a huge amount of activity in your transaction log. When you're doing that in place on a table, maybe your transaction log fills up, or maybe the person who's running it clicks cancel, and then you've got this huge rollback going on. These tools that script the changes don't want to get you into this situation. So I'm guessing, I didn't write these tools, but it makes sense that part of the logic would be, let's limit our bets on this. And if we think it's possible that this might happen, we're just going to do the new table, we're going to insert the rows, and if it gets canceled in the middle, all right, well, maybe we have to cancel a big insert, but we haven't sort of messed with a possibly big, large existing object that's there. This size of data operations, when you add new columns, it doesn't happen all the time. It only happens sometimes if you're adding a column that you say it's not nullable and there's a default value, because it has to actually go through and put that default value on every single row. There is an exception to this. In SQL Server 2012, in Enterprise Edition, they added a feature just for Enterprise Edition where it sort of magically knows the default and doesn't have to do the size of data operation. If you're on SQL Server 2012 and higher, you might choose to custom code and go ahead and say, no, we're just going to add this column in place and it's really fast on our table. You might also decide, oh, and by the way, there's a great article on this. If you're curious about trying this out, it actually doesn't work for like all data types, which makes sense. It shouldn't work for like in Varchar Max or anything like that. And it only works for things like constants. If you've got something like new ID or you want a different value on every row, it won't do that. Remus Rusanu wrote an article called Online Non-Null with Values Column Adds in SQL Server 2012. Got a link to it in the blog post on this Dear SQL DBA episode, so you could click through to that. The other thing is, if you've got a big table and maybe your standard edition and you want to add a column, you do have the option to add the column and make it nullable. And then you have code that rolls through and updates batches of rows, which you've carefully indexed and crafted your indexes so that you're not doing big locks. You can populate the value and kind of work around it that way too. Or you could choose to create a new table, insert, switch, there are many ways you could do this, but you do have to pick, and maybe you have Enterprise Edition. This is a good reason why it's great that when you test on Developer Edition, it has all the features of Enterprise Edition if you have Enterprise Edition in production. This is a little tricky. Let's say I've got Developer Edition in my dev environments and in my staging environment, but I've got Standard Edition in production. This is one of those changes that, it could be much faster in test and staging than when you get to production, and you've got to look out for it there. So this is a tricky one, right? So it's worth knowing about. I'm not sure if it's worth paying for licensing for Standard Edition and staging though. Not sure I'm saying, because that's a lot of money difference there, right? The real way, there's no magic feature bullet to avoiding downtime with schema changes. A lot of it is really process and experience. And I've worked in environments where we rolled changes to the SQL Server on all sorts of weekdays at all sorts of different times of the day. And we would hit issues. The biggest problems that we had in the environments where I've done this were that sometimes when the code release didn't have the exact desired effect, sometimes when the release was buggy, it would cause a problem that was urgent, and then we would need to release a fairly quickly written hotfix to production, which sometimes could be followed by another fairly quickly written hotfix. This isn't to say that testing hadn't been done, it's just that not every change is going to be perfect. And when you are releasing changes throughout the week, you are going to release some throughout the week that aren't going to be perfect. That's the truth no matter how often you release, is that not everything is going to be perfect unless you do work for NASA, which, I mean, some people are perfect, but not, most of us aren't, right? So that could be sticky. But like I say, I think that was going to be sticky whether we were releasing the code on the weekends or on a weekday. And also, our biggest problem was actually transactional replication, because we had a lot of replication in the system for various uses, and sometimes change to the database, sometimes a schema change, sometimes just updating data in the database. It would sometimes put a lot of rows into replication and it would get slow, or a small metadata change upstream would cause, and there's many downstream data processing systems, sometimes it would cause a massive processing job to happen downstream and then cause delays in reporting systems and other parts of the system. Whereas, the actual deployed change was, oh, this is very simple. We're updating a couple values, right? Goes in fast. But while there were bumps along this road, we actually got really good at deploying changes. And I became a big fan of deploying changes, including schema changes, regularly through the week and at different times of the day. Because the truth is, for the DBA, hey, I would much rather have, if I am doing break-fix work, I would much rather respond to break-fix work during the day when I'm in the office rather than at 3 a.m. when I'm really tired. So it actually, I preferred code changes that released early in the day. I just didn't want to release code changes after 4 p.m. That's not good for anyone, right? You don't want things to go wrong when the developer who can help write the hotfix is in the middle of traffic. That's what you really want to avoid. So that's an important consideration, is actually time of day. But other things, we would always release schema changes before application changes. In other words, if there's a new feature that's going to need columns to be added to a table, that column change would be coded and tested well in advance of the feature ever appearing to a user. That way, if the release where the schema change was being made in, if something went wrong with adding that column and it didn't happen, the whole release didn't have to be rolled back because nothing that was super dependent on it was in that release. So loosely coupling the changes and releasing them in stages, essentially we'd get all of the plumbing for a feature in the database and all the data changes done before anything was visible to the customers. It made scheduling easier. It also made it easier for us to do things like, okay, we're gonna say maybe we only want to release schema changes to this application on certain days of the week. It just simplified scheduling. We also found that it really, really helped us to test in a full-scale pre-production environment. We had staging environments in all of these places where releases would go into that staging environment. They would be deployed by whoever was going to deploy it in production using the exact same tools. The environments needed to be set up with the same data sizes as production. So if there's a 2 terabyte database in production, it needed to be 2 terabytes in this environment. We also configured them exactly like production in terms of if it's a cluster in production or if it uses mirroring in production, it does that here in staging. If there's replication, it's got to have replication here too, so that we could start to identify things like those downstream changes where a little change over here causes a much bigger effect over there. This is hard to make it, because you have to figure out how much is it worth to us to make it as identical as we can. At first, folks think about the hardware cost of this environment. And the more similar you make it, the more your hardware is going to cost, but it does have rewards, because the more similar your hardware is, the better you're going to be able to estimate, hey, how long is this change going to take in production? You can save on licensing in the staging environments though. As long as you are only using the staging environment for testing and there's no production use of data, no customers are using this data, it's not being used for reports, you can license it with SQL Server Developer Edition, which is much, much cheaper. You do just have to be aware if you're using Standard Edition in production, using Developer Edition in your staging environment could potentially make certain things happen faster there, because in staging, you'd have access to this feature for adding non-nullable columns with default values. So that's kind of like, it's hard to make sure you hit all the words right in that sentence. That might be faster. There are certain things like SQL Server can do advanced read ahead in Developer Edition and Enterprise Edition. So scanning large amounts of data, you could get advanced read ahead boost from that. You could get potentially merry-go-round scan boosts if you're testing multiple reports that scan things. So you do have to be aware of that. Developer Edition, though, is much cheaper than Standard Edition, so most folks do choose to use that from a staging environment. If you're starting deploying lots of schema changes during the week and you don't have this staging environment, don't panic. What's going to happen is that you're going to have the conversation a lot. What went wrong and how could we avoid having it go wrong again in the future? And talking about this staging environment is going to be one of your biggest tools to be able to suggest, to say, if a lot of folks detect these problems by having this production-like staging environment that isn't a dev environment for them to deploy to before it goes to production. You are going to need to customize some code too. You can't use the automatically generated code to deploy everything if you're trying to limit downtime. So you need to work out a way to say, when we see that the automatically generated code just isn't fast enough and we need to do something custom, what is our process to generate that code? How does it get checked in? How does it work with the dev cycle? Because of issues like this, when I worked with teams where we regularly deployed code, it was really helpful for me to stay in regular contact with the developers. I often stopped by their stand-up meetings, and it wasn't that I understood everything that was going on in stand-up. It was that I wanted them to know who I was and that they could ask me questions, and I wanted to be around. We also had some developers who became experts on changing the schema in the database in SQL Server, and they would often help pair up and review with other developers too. Not every developer has to be an expert at this, but sort of as you work with this over time, and as you hit these bumps, you'll identify people who are interested in it and who care about it and are curious about, hey, how can, what are the quirks of this and how can we get good at this? And they really become the experts. To get it all to work, you really need management and whoever is leading all the teams to be okay with screw-ups that cause downtime. This is something that I really didn't get. It was very counterintuitive to me. And I was like, no, the whole point is that we're not really supposed to have much downtime. It really bothered me when we had downtime, even, if it wasn't waking me up at 3 a.m. And the thing is, it really has to be okay, because to do this well, you have to be able to learn from the mistakes as a team. And you have to be able to avoid them. You need to really be able to communicate well and have a post-mortem after an incident that isn't just, you made this wrong and so you're bad, right? It needs to be, hey, we screwed up. We don't want to focus too much on, who did it and why they're dumb. We're going to just focus on how to make it not happen again and move on. But really, how does it not happen again? If you've got a culture of blame, where people are sort of afraid of being blamed, because that's what happens in cultures of blame, it actually gets really hard. No one wants to go to the post-mortem, because even if it's not your fault, you really don't want like everybody being like, no, actually it would, that's where things get bad. So you've got to kind of be comfortable with the fact that to make an omelet, you're going to break some eggs to really get into this. And then after you're doing it for a while, you get better and better. You learn from your mistakes and your screw-ups become less. But of course, what if you're in an environment where it's not okay to have downtime? There are truly many environments where like it is just not okay to have some downtime because people are going to die, or just large amounts of money and value for the business is going to be lost. It's totally true that those exist. And in those environments, most of them, either you shouldn't be deploying changes to the schema on a regular basis. You should have planned downtime to avoid those changes. That's many of them. But then many others, you need a much more custom and expensive approach. If you really, really can't afford to have downtime, you also really can't afford for the SQL Server to be offline. So you should be thinking a lot about high availability and disaster recovery. But you may also put in a lot of custom architecture so that you can make changes in a more planned way. Perhaps you have ways that even if you can't write to the database, reading of critical data is still online via application caching or other caching. Perhaps there's a way that if writes can't happen to the database right now, they could be queued. This is all going to, how it's done is going to vary, wildly by individual applications. It's going to take developers and database people and IT people to figure it all out. So in those cases, there's special things you can do, but it's certainly not as simple as one database administrator. All right, so that is our story on how you can, as a database administrator, limit downtime when applying schema changes. I wish I totally did know of a magic button that would make this much easier, but the silver lining and the bright side here is definitely job security for the SQL Server database administrator, at least for now. Thank you for joining me for Dear SQL DBA. I'll see you again soon.